Okay, so this references the exploration that the book had you do, but I'll reference our little activity. Okay, so we basically figured out that the sum of the lengths of the two smaller sides of a triangle has to add to be greater than the third side. Okay, but that's actually true kind of in general. The sum of any two sides or side lengths of a triangle must be greater than the third side. Now, obviously, the one we normally would go to would be the two smaller sides, right? Because they're the smaller sides, and they have to add to be greater than the third side. Okay, but that's the idea here. So really, any of these inequalities must be true. So AB plus BC must be greater than AC, but also BC plus AC must be greater than AB, and AC plus AB must be greater than BC. But like Melissa correctly pointed out, really the important one we have to look for is the two smaller sides, and make sure they add up to be greater than the third side, the greater side, or great S side. Okay, so if we look at the next page, all right, we have some examples. All right, so the example 1 here kind of shows us, or it says, use the triangle inequality theorem to tell whether a triangle can have sides with a given lengths. Explain. Okay, so the example we're given here is 4, 8, and 10. All right, so they say, all right, 4 plus 8, is that greater than 10? Yes. Okay, 4 plus 10, is that greater than 8? Yes. And then 8 plus 10, is that greater than the third side 4? Yes. Okay, so conclusion, the sum of each pair of side lengths is greater than the third length, so a triangle can have side lengths of 4, 8, and 10. Okay, now we look at the 7, 9, and 18, though. All right, and so here if we see that the 18 is in this box, that means what two sides must go in these two boxes? Anybody? So here we're looking at these 7, 9, and 18, so what must go in these two boxes? Anyone? Am I blocking it too much there?
7 and 9?
Well, so it's got to be 7 and 9, right? So then 7 plus 9 gives us 16. Okay, is 16 greater than 18? No. So we don't even need to do the rest of this because we already have a fail. Okay, once it fails once, it doesn't matter what the other ones do. Okay, so this triangle is impossible. Okay, because 7 plus 9 is less than 18. Okay, it fails the triangle inequality theorem. All right. So we look at the question like number 4 then. Can an isosceles triangle have these side lengths? 5, 5, and 10. Evan, what do you say?
Yes, because they're... No, never mind.
So never mind, you don't want to answer, or never mind, you don't want to say yes.
No, I think it's wrong.
You think it's so it's incorrect now.
Yeah.
Okay. So what makes it incorrect? I see two congruent sides here. That makes it isosceles, right?
Not greater than 10.
Right. So 5 plus 5, right, is not greater than 10. It's equal to 10. So no. Okay. 5 plus 5 is equal to 10, not greater than 10. Or something along those lines, right? So the triangle cannot exist. Okay? I don't know, 5 seems very straightforward to me. How do you know that the triangle inequality theorem applies to all equilateral triangles? It's like, I think that's kind of obvious, right? You're going to always, what's special about an equilateral triangle again? What makes an equilateral triangle equilateral? What's that mean? All the sides are equal, right? So if you have a triangle that's got 5, 5, 5 for its sides, then 5 plus 5 is greater than 5, right? The other two sides added together will always be greater than that third side. So I'm not going to bother writing that one down. That just seems kind of silly to me. 4 was kind of silly as well, but anyway. Okay, so real quick, 6 and 7, give them a shot. Tell me whether you think they are triangles or not. Okay, let's take a look there and see. Let me just take 2 seconds. Okay, are they or are they not triangles? Very good. Have fun. Okay. This is weird. Okay. So let's see here, Julia, number 6. What do you say?
No.
Nope. Okay. And so what? How does it fail?
Because 12 plus 4 equals 17. Wait.
12 plus 4 is not 17. 16, which is not greater than 17. Okay, so there you go. So yeah, so 12 plus 4 is greater than 17, so not a triangle. Or sorry, 12 plus 4 is less than 17, actually, right there, sorry. Okay, so that means it's not a triangle. Okay, number 7, let's go to Adam. What do you say? Number 7.
I said yes.
Yay or nay? Yay, you say, okay? So, how did you determine that?
24 plus 8 is 32. 32 is greater than 30.
Yep, so there we go. The two smaller sides are greater than the third side. Okay? So yes, that triangle could exist. Could exist. Okay? Alright, we are going to skip that next one there with the compound inequality stuff. Alright, but I do want to move on to page 345. Right here. Okay. And in addition to this whole idea of, the triangle inequality theorem, we also have something that's probably like intuitively just makes sense, but it does need to be stated because it's not a trivial matter, I guess. So, basically, we're just going to skip right down here to the side angle relationships in triangles, okay? So if two sides of a triangle are not congruent, then the larger angle is opposite the longer side, okay? So for example here, if we say that AC is greater in measure than BC, which is like visually we can kind of see that, so it kind of makes sense, right? Then it makes sense that the angle opposite AC, which is angle B, should be bigger than the angle opposite the BC, which is angle A. And that's true, right? Doesn't B look bigger than A in this picture here? And AC certainly looks bigger than BC. Okay? So, the longest side is always opposite the longest angle. The shortest side is always opposite the shortest angle. And the middle side is always opposite the middle angle. Okay? So, let's see here. If we flip that over, and look at page 346, and you can see that in play right here. Okay? You see we have the three sides of this triangle. So the longest side clearly is the AC because it's 15. Therefore, the greatest angle will be opposite that. So opposite AC, B. Okay? The shortest side is AB. Opposite that is 10, so that's our shortest angle. And so then in order, the angle measures from least to greatest would be C, then A, and then B. Okay? You got it. Okay, so letter B, go ahead and give that one a shot. Okay, based off the side measures there, come up with, fill in those blanks. Okay, fill in the blanks there. So Patrick, what's the longest side here in this picture? BC, you got it. Okay, and so therefore, Patrick, the greatest angle measure is going to be angle what? Very good. Yep, angle A. Okay, thank you. Let's go to Stephanie. What's the shortest side length here? AB, you got it. And therefore, that means the smallest angle is going to be what? Angle C. Good. And so then the order of the angle measures from least to greatest, okay, is going to be what there, Mary?
Measure of angle C, measure of angle B, measure of angle A.
Yep. Angle C, the measure of angle C, the measure of angle B, I see what you're saying there, and the measure of angle A. Okay, that's right. Or if you just said angle C, angle B, angle A, that's okay as well. All right. All right. So that was for sides. I mean, sorry. If we were given sides, finding like the smallest angles and largest angles and the medium angles, right? But here, same thing is true for the angles to the sides. If you find the biggest angle, then opposite that would be the biggest side. Smallest angles opposite the smallest side, and then the middle angles opposite the middle side. Okay, basically just summarizing that right there on the bottom, page 346. All right, we're not even going to bother doing some example problems here because I think you guys have got it, right? So I mean, here, for example, right, just in the one that they did for us, you have the three angles in this triangle. Okay, since the greatest angle is angle B, the largest side is going to be AC. The longest side will be AC. Since A is the smallest angle, then BC will be the smallest side. Length, and then 50 degrees AB will be between those two. Okay, so that's that. All right, and that's all I want to look in that section. But there's one other quick section I want to look at real quick. Page 327. Let's go to that one. So it's the previous section there. I also want to look at isosceles and equilateral triangles real quick as well, just to hit this real quick. Okay. So again, we're on page 327. 327. Page 327. We're going to go backwards here, yeah. Okay, 327. All right, so we're going to look at some quick properties of isosceles and equilateral triangles too, because that was a quick little, lesson today, and I want to make sure we get this into, just so we can kind of move along here. Remember back, we had talked about isosceles triangles, right? And there are some special vocabulary that comes with isosceles triangles, okay? The two congruent sides are known as legs in an isosceles triangle, right? Which is kind of like right triangles too. We have legs. The legs in the right triangle are the ones that touch the right angle. Here in an isosceles triangle, the legs are the two congruent sides. The third side that's not congruent to the other two is a base, called the base, okay? It's not necessarily on the bottom, but then the two angles that touch that base are called the base angles. Okay. By the way, real interesting here. By definition, it says an isosceles triangle is a triangle with at least two congruent sides. So what other kinds of triangles, besides a regular just isosceles, what other kinds of triangles are also isosceles? If you need to have at least two congruent sides, true?
Equilateral.
Yeah, equilateral will also be considered isosceles triangles. Interesting there. Okay, so anyway, there's our vocabulary refresher. If you turn the page over though real quick, and we're not going to go through these proofs just for the interest of time, but it says here for the isosceles triangle theorem, and again it's kind of like intuitive, it kind of makes sense, right? If two sides of a triangle are congruent, then the two angles opposite the sides are congruent. Okay, so, and we'll flip over here to like, it doesn't go to where I want to do. There wasn't an example problem. What? Oh, hey, Mike. Oh, you brought us pizza. That's not enough for the rest of the class. You should probably go back and get some more. So.
Okay, I'll be back.
See you there, Mike. Yep. All right. Well, I'll take a cheese. Anyone else make some toppings? No, that's all right. Yeah, very good. That is mean to bring in pizza, though, Mike. That's real mean. No, I understand. You can just wherever you want to sit there. That's fine. We're doing some notes, okay? If you want to grab your book out of there, over there, actually, we're on page 328. So if two sides of a triangle are congruent, then the two angles opposite sides are also congruent. So that means in an isosceles triangle here, and we're not going to do this proof, like I said, if we have that AB is congruent to AC, that means that angle B will be congruent to angle C. Okay? Likewise, in the opposite direction, if we have two angles congruent, the sides opposite them will also be congruent. So AB and AC must also be congruent. Okay? So you can use that property. All right. And then on the back of that page, I just want to go through a few more properties here too. Obviously, we already know this. This is so, I don't even know why they devote a whole page to this, but if a triangle is equilateral, then it's equiangular. Duh. And if a triangle is equiangular, then it's equilateral. Duh. Okay, right? We know that. And so then we have interesting kind of problems like this. We go on 331 now is where I am. Sorry, I'm jumping all around, but I just want to get through this stuff so I can give you guys some time to start on your homework too. Looking at a problem like this, okay, Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. It is an equilateral triangle with the following dimensions in centimeters. So for some reason, she decided to torture the people that are making her banner, and she wanted to make an algebra problem out of it instead of just telling them the measurements using normal inches and centimeters. Okay, so what is the length? This is like a real life application here, guys. Real life. Okay, this is real life. So here we go. This triangle, what kind of triangle is it, right? Well, if we have these two base angles congruent, okay, if we know that side AC is 6x minus 5, what does that mean AB has to be? 6x minus 5 as well. You got it, okay? So there's that. Now, somehow we have to come up with an equation here. AC is congruent. Oh, okay. Hello, welcome, Maria. Oh, you didn't bring us any pizza.
No, sorry.
There were no leftovers.
I didn't even eat pizza. I had pepperoni and cheese.
Nice. We had some pasta earlier, so we're all a little full right now. Yeah. Well, I'll get you some pasta. I got some over on my desk. Actually, yeah, it's over my desk, I guess. Okay. I'll get you some later. Oh, it's right here? Oh, yeah, here you go. I'll get some pasta. You want some pasta? I'll get some later. Get some later. Not right now. Okay. Oh, okay. It is an equilateral triangle. So if it's an equilateral triangle, that means, okay, we can set these sides. So to set up an equation here, we're like, 6x minus 5 must equal 4x plus 7. We can solve that and get x equals 6. And then to find the individual side length, we just plug that 6 back in for the x. Very straightforward. Okay. Looking down here at angle for letter B, though, the measure of angle T. Okay. Ideas here, and again, we're going to skip all this mess trying to fill in blanks. I don't like trying to follow what they have to say, so we'll just do this on our own here. Okay. Alexis, did you bring me any pizza?
No, I didn't.
You didn't get pizza? What did you get? Macaroni and cheese?
No, I got French fries.
Ooh. Solid.
I'll make sure to bring something next.
No, it's okay, thank you. I'm just giving you a hard time. We'll see it, no problem. All right. So this triangle right here, let's actually do an actual problem now without being distracted with food and stuff, all right? So we got a triangle. It's an isosceles triangle. Okay? Anyone have any idea? How can we go about setting this up? Yeah. Tanner, what do you say? 3x plus x plus... Where'd you get the other x from? How do you know that? We have an isosceles triangle, right? If TR and TS are congruent sides, that means their opposite angles must also be congruent. So if this one's x, this one must also be x. And that's exactly right. And since we know all the interior angles of a triangle have to add up to 180, okay, Tanner's got it. Okay, so x plus 3x, 5x equals 180. Divide both sides by 5. X is 36. Okay? And that's it, right? X is 36. That's our answer. No, that's not our answer. What do we still have to do? Plug it into what? Right, so we want to find, here's our question, measure of angle T. T is 3x. So x equals 36 is not done, right? We are not complete yet. We have to do 3 times 36, okay, which is 108 degrees. That is our final answer. Okay, angle T is 108 degrees. So please make sure you're answering the question that is being asked. Okay? All right, I'm feeling pretty good about that. Hopefully you guys are too. We'll see. So let me give you guys your assignments. Okay, so here we go. Cut the video here. Boom.